Welcome to part 1, or actually part 2, of our 10th learning workshop, which is compounds with oxygen and sulfur. Last time we named and drew structures for alcohols. This time we're going to be focused on ketones, ethers, and aldehydes. And ketones, ethers, and aldehydes. Ethers are actually pretty easy to name. Well, actually, what I should say is there's two different ways to name ethers. There's the common way and there's the Iupac Iupac way. Now, the Iupac way is a little bit more complex, but most professors only want you to do the common way of naming it. So, let's go ahead and just jump right into this, shall we? I'm going to zoom in the screen. I don't know if you're going to be able to, you can zoom it in if you want to see it. Zoom it in, so just first three. Now, have you done anything with ethers yet? Or is this something that's new? Okay. Did your professor want the Iupac naming at all, or did they just want the common naming? Oh, they want both. Okay. All right. I'll go through both of them then. And I'm going to just go ahead and I'll call this up. Do the top as the common, and I'll do the bottom as the Iupac. And Iupac stands for the International Union of Pure and Applied Chemistry. Not that that's important or that you need to know that, but, you know, might be helpful. Okay, so for common naming, all you have to do with an ether is to look at the two sides of the oxygen. So here's one side of the oxygen, and here's the other side of the oxygen. And you name each side as a substituent, as a branch. And so this is, of course, a 2-carbon branch. And what would a 2-carbon branch be called? What would a 2-carbon branch be called? Yeah, ethyl. And this one is a 5-carbon ring. And normally, what would you call a 5-carbon ring like that? Cyclo what? 5 carbons? Cyclopentane. Very good. But because I'm naming it like a branch rather than as a main chain, instead of calling it cyclopentane, I'm going to call it cyclopentyl. Just like instead of calling it ethane, I call it ethyl. So in this case, for the common naming, what I would do is I would call this cyclopentyl space ethyl space ether. Cyclopentyl ethyl ether. And I notice I put a space in between each word. For ethers, with the common naming system, I would do spaces. Now, alternatively, if I'm doing the Iupac naming, what I do is I look at both sides, and I look at the longest carbon chain, or the biggest carbon group. So which one of those two groups that's attached to that oxygen is bigger? Which one has more carbon? Yeah, the cyclopentyl. So for the Iupac name, this I actually deal with this just a little bit differently. Instead of treating both sides like a substituent, I treat the longest carbon chain as if it is the main chain. So this is actually going to be cyclopentane for the Iupac name. And then the remaining carbons along with that oxygen become a branch. But a very special kind of branch. Because it's 2 carbons with an oxygen, I'm not going to call it ethyl. I'm going to call it ethoxide. So it's going to be ethoxide. Now, here's the thing. Normally, we would number the longest carbon chain, and of course, with the cyclo group, the longest carbon chain, the number one is going to always start from the wherever the substituent or functional group is, if there's only one substituent or functional group. So this, of course, would be 1, and then I could do 2, 3, 4, and 5. But here's the thing. It has to be 1, right? And if it has to be 1, then I don't actually have to put the 1 there. In which case, I would just name this as, oh, sorry. I did make one little mistake. I don't call it ethoxide. I call it ethoxy. Ethoxy. Normally it would be ethyl, but I call it ethoxy. So for the Iupac name, it would simply be ethoxy cyclopentane with no numbers. Does that make sense? Any questions? Cool. So what would the common name, so that's how we do Iupac name. What would the common name be for number 2? Look at both sides. What would the common name be? What do you think?
Okay, it's easier for me to talk. So I don't think it's a pentane because there's an oxygen in the middle.
Sorry,
So
your voice is very quiet.
Okay, can you hear me better now?
Yes, I can. Thank you.
Okay, so don't you name either side of the oxygen?
You name either side of the oxygen. So on the right-hand side, that would be what kind of group?
Propane, propyl.
Well, on the right-hand side, this is actually just 1 carbon here and 1 carbon here, right?
Oh, yes, you're right. So it would be an ethyl.
And on the left-hand side, it's
the same.
So what would I call this for the common name?
Diethyl?
Diethyl, yeah. I mean, some might assume like, oh, well, the ethyl, ethyl ether. Well, if it's the same, you can just say diethyl. Diethyl space ether. And if I have the Iupac name, then one of these becomes a branch and one of them becomes substituents. Because these are identical, it doesn't matter which one is the branch and which one is the main chain. So I'm just going to go ahead and circle in black the one that I'm going to make the branch. Or actually, no, I'll circle it in blue. All right. So this, strangely enough, this is my branch. This in blue, it's my branch. And the main chain is in the orange. So what would I call that branch? What would I call that branch?
Ethane?
Well, the main chain would be ethane. You're correct. But what would the branch be called? So the main chain is 2 carbon. Ethoxy, exactly. So this would actually just be ethoxyethane. It feels weird, but that's what you would call it.
Okay.
All right, let's take a look at I don't know. Let's do 3. Let's start with number 3 by doing the Iupac name for this one. All right. So here's the deal. Which side has more carbons? Which is the longer chain?
On the right side?
On the right side, very good. So I'll circle the longest carbon chain in blue. So I can see now that I have two substituents. I have one on carbon number 2, and I have one on carbon number 3. I mean, carbon number, well, I have to start naming from the side that's going to give me the lower number for my numbers. So in that case, I'll start naming from this side. This will give me 1, 2, and 3. So because it's a 3-carbon chain, the root name is what?
Prop?
Yeah, propane. And ethers in the Iupac naming system just get named as alkanes with the substituent. So it's propane. But then I have a bromo group, and I also have this other stuff over here. So what would I say? What is this other branch going to be called?
Methyl? No.
How many carbons is it?
Oh, ethyl.
But it's also attached, it also has an oxygen as part of it, right?
So it's that ethoxy again?
Exactly, it's going to be ethoxy. So, but we also have a bromo group, and with this, we don't give priority to any group, even if it's an ether group, even if it's an ethoxy group, we don't give priority to it. We just list it in alphabetical order. So this is going to be 2-bromo. I actually should change my lettering scheme. I'm not making any sense here. I'm trying to be consistent here. 2-bromo dash 1 dash ethoxy. 2-bromo 1-ethoxy propane. Does that make sense?
Yes.
And now, if you were to name this with the common naming system, it would actually be a little bit more complex. This is going to be a ethyl group, obviously. With the common naming system. I'll actually redraw that so that it only includes the carbons. So it's not to confuse ethyl with ethoxy. And this would be a propyl group, but this is what's known as a complex substituent. It's a branch that has a branch, effectively. So propyl is the root name, but P comes after E. So in that case, when I name this, I would name it, I'll name it an orange, why not? I'll name it ethyl space 2-bromopropyl space ether. Ethyl 2-bromopropyl ether. That's how you would do the common naming. Probably won't get a common naming one like that. Okay. So I want to give you guys a shot at this. Go ahead and do number 4. And when you I'll give you some time to work on number 4. Raise your hand when you think you have an answer that works. Okay? Or if you give up.
Okay.
So, do both the common and the Iupac.
Yes. Okay.
All right, we got one. How about you, Krissa? That's okay. Would you like to go over it, or do you want a minute? Okay, so number 4, in this case, if you were to do the Iupac naming, um, or if you were to do the common naming, we'll do that first. You have two branches. You have this branch and you have this branch. The branch on the left is composed of 2 carbons, so once again that's an ethyl. The branch on the right is composed of 3 carbons, so that's a propyl. But when a propyl group is attached in the middle, when a propyl group is attached in the middle like that, we have to actually, we call it something else. We don't simply call it propyl, we call it isopropyl. Yeah,
Okay.
isopropyl. And you should have learned about that particular substituent. That's one of the ones that's listed in the book as common substituents, isopropyl. And then there's also ethyl. So in this case, alphabetical order, ethyl comes first. So the common name would be ethyl space isopropyl space ether. And then from there, you can go ahead and uh, proceed to, from there you can go ahead and proceed to do the Iupac name. Now the Iupac name, you're going to use the longest of the 2 carbon chains, which is going to be the propyl. And so I'm going to go ahead and delete my little orange circles. So the longest carbon chain, we're going to circle it in blue. This is my propyl. They're no longer isopropyl. And then the other, the other one, the 2 carbons with the oxygen, will then be a branch. And if the 2 carbons with an oxygen is a branch, which I'm going to go ahead and mark as a orange square. So here's your branch, and then there's your main chain. Well, I have to outnumber my chain because that oxygen could be attached to any one of those 3 carbons. I'll number my chain, so there's 1, 2, and 3. So this is the O with the 2 carbons attached to it. The ethoxy is on carbon number 2. So the name for this using the Iupac system would be 2-ethoxy propane. Is that what you got?
I just didn't have the 2 on there. I had the rest.
Oh, okay, well, good, good. Yeah, unfortunately, I mean, you wouldn't necessarily need it if it was a 2 carbon chain, like the one that we had when it was ethoxyethane, because in that case, either way you put, regardless of whether you put the oxygen on this carbon or this carbon, it's still going to be carbon number 1, right? So
Right.
for that one, you
Yeah.
don't need it. But with a 3 carbon chain or more, for alcohols, um, other functional groups, for things like that, you do need to put a number indicating where it is. Um, but very good, very good. So now we go to ketones, ketones and aldehydes. Now ketones and aldehydes differ in only, well, they differ in several ways, but in appearance-wise, they differ only in one major way. Ketones and aldehydes both have a double bond to oxygen. However, ketones have the double bond in the middle of the chain, and aldehydes have the double bond to oxygen at the end of the chain. In other words, on the number 1 carbon. Since ketones and aldehydes are both functional groups, you will basically, since they're both functional groups, you will basically always start numbering from the side that's closer to that functional group, and the functional group has to be part of the longest chain. So essentially, anytime that C double bond O is on carbon number 1, that's an aldehyde. And anytime it's any other carbon, carbon 2, carbon 3, whatever, it is going to be a ketone. So in this case, for number 5, is that an aldehyde or a ketone?
Ketone.
It is a ketone. And since it's a ketone, I'm going to start numbering from the side closest to the ketone group. This will be 1, 2, 3, 4, 4 carbons in the chain. And with a ketone, the ending is ONE. So just like ketone. And so in this case, it's 4 carbons, so the root name would be what?
Ute.
Bute. So butanone. And you'll notice that instead of for the alkenes and the alkynes are really the only exception to this, but usually the root or core name involves everything up to the end. The first N, so butan, methan, propan, hexan, and then what changes is the ending. So in this case, butanone, or if it's an alcohol, butanol, or if it's, but if now in this case, do I need to put a number in front of butanone? What do you think?
Yes, you do.
Actually, you don't. And
It's a ketone.
I don't mean to be confusing about it, but because it is a ketone, the double bond O has to be in the middle of the chain, right? And since it has to be in the middle of the chain, the only two options for it to be is on one of those middle carbons or on the other, the ones that are labeled 2 or 3. But if double bond was on the carbon labeled 3 right now, you would actually start numbering from the other side, wouldn't you?
Right, so it's a 2 either way.
Yeah, so it'd be a 2 either way. So now that said, will it be marked wrong if you put 2-butanone? Probably not. Probably not. It would probably be marked wrong if you put propanone, if you put 2-propanone. But with butanone, it's a little bit more of a you don't need the 2, but if you put it, usually professors won't mark you. They won't ding you. All right, so that's it. That's all you have to do with that one. Let's look at this one that's a little bit more complicated. Number 6. So, what's the longest carbon chain? How many carbons are in the longest carbon chain?
5.
5, yep. And I'm going to go ahead and mark those here. And the longest carbon chain must include the functional group, so we know it has to probably start over by that double bond O. So this will be carbon 1, this will be 2, and this will be 3. But here, where do we go from here? Do I go down or do I go across? What do you think?
I guess across, because don't you have to incorporate the other one?
Yeah, you have to go across here because even though going down would give you 5, whenever you have a choice as to between two paths that are equal in terms of the longest carbon chain that they'll form, you always have to go to in the direction of the one that has more branching. And going across has more branching than going down. Does that sound familiar?
Mm-hmm.
Apologize for like the chainsaw sounds in the background. We have people doing work on our chimney at the moment. All right, so that's the longest carbon chain, which you can see now that you actually have two you actually have two substituents, two branches. So I have a branch here and I have a branch here. Okay. So the root name for this compound is what?
Pentanone?
Pentanone. So this is a pentanone. Pentanone. Um, so what number do I put on it, or do I put a number? Would I give the ketone group a number?
Yes.
What would the number be?
2.
Mm-hmm. Yeah, so you would get a number. Yeah, in this case, it would be a 2. So 2 pentanone. Now I have to include my branches. Now the top branch is a 1 carbon branch, so that would be called what?
Methyl.
Methyl, very good. And the bottom carbon, bottom branch is 2 carbons, so that would be called
Ethyl.
ethyl, very good. And so now all I have to do is put those branches in alphabetical order. So this would be
3-ethyl, 4-methyl, 2-pentanone.
exactly 3-ethyl, 4-methyl. Ah, I'm trying to scrunch it in here. 2-pentanone. 3-ethyl, 4-methyl, 2-pentanone. 3-ethyl, 4-methyl, 2-pentanone. Cool. Very good. Now, let's look at something that's called, let's look at our aldehydes. Now, for 7, 8, and 9, which of these three is a ketone, and which of these three are aldehydes, and which of these three are ketones? Let's start with that. 7 is an aldehyde, very good. What about 8?
I think 8 is as well.
8 is actually a ketone. You can't have a cyclic aldehyde. Yeah,
Oh.
8 is a ketone. You cannot have a cyclic aldehyde because if the double bond O is directly connected to the ring, then a ring doesn't have a beginning or end. So yeah. So I mean, I understand why you would have thought that it would have been an aldehyde because of what I said. I did say if it was on carbon number 1, then it would be an aldehyde. The rings are an exception to that because for it to be an aldehyde, it basically has to be at the end of a chain, and there's no chain in a ring. So, Carissa correctly surmised that 9 is actually an aldehyde. It's not direct. The double bond O is not directly connected to the chain. It's just adjacent to the chain. Um, so we have 2 aldehydes, 7 and 9, and we have 1 more ketone. Well, let's name our number 7. What is the longest carbon chain that I would use here for naming this aldehyde number 7? Bromine's not part of the chain, by the way. And while 6 is the longest carbon chain, the chain that we're going to actually use for naming this is 5, because the longest carbon chain must include the functional group. And so if I'm looking at these carbons here, I have to include the carbon that has the functional group. In other words, I must have the C double bond O. If it is an aldehyde, I have to start from that position. So this is automatically number 1. which means this has to be number 2. And then if I count, I can go down 3 and 4, but it would be longer to go 3, 4, 5. So that is my longest carbon chain with the functional group. Remember, when you're naming, the functional group must be part of the longest carbon chain, even if it makes the chain shorter. So that leaves us with 2 branches. We have a bromo and an ethyl. So we have a bromo and an ethyl. Now, what would I know? So the ending for an aldehyde is al, just like the ending for a ketone is -one. The ending for an aldehyde is al. So this would be pentanal. Yep, pentanal. Pentanal. So do I have to include a number for aldehydes? What say you? You don't, because it's always on carbon number 1. You never need a number for aldehydes, so it's just pentanal. In that case, I'll just add my branches, and this will be, 5 bromo, 5 bromo, and then 2 ethyl. And actually there should be no space there, sorry. 5 bromo, 2 ethyl, pentanal. I apologize for my abhorrent, writing. Yeah, kind of. There you go. 5 bromo, 2 ethyl, pentanal. My marginally illegible writing. Now for number 9, when a benzene ring, so one of the things you're going to notice is these benzene rings are actually pretty special. I'm going to mark the carbons of the benzene ring. When a benzene ring is attached to certain other groups, it changes it, it gives it kind of a new name that is not your typical name, it's not your standard way of naming things. So anytime you see a benzene ring connected to a functional group, chances are it has some sort of a interesting, unique name. In this case, when benzene is attached to a 1-carbon aldehyde branch like this, we would call this whole thing, not including the chloro, would be referred to as benzaldehyde. Benzaldehyde. The chloro group is attached to it, and so since the most important thing is the functional group, I'll put a 1 on the carbon that's attached to the aldehyde group. So 1, so that means this will be 2 and this will be 3. So this is going to simply be 3-chlorobenzaldehyde. Benzaldehyde. So let me ask you this. Would you like to take a shot at number 8? And we'll go over it together in just a couple minutes. Okay. Just raise your hand when you have an answer. Frank, you got an answer? Or is this one of those other kind of raise your hands?
I think I got an answer, but I don't know. It came too fast, so I got 2 methyl, 3 ethyl pentahexene, no, pentacyclopentanol.
Dang, Frank. Rock on.
Okay, it worked. Yeah, was it?
Yeah, you got it, bro. Yes,
Okay.
it's three. It's 3 ethyl, 1 methyl. Ah, I don't know what that was. 1 methyl. I didn't like me.
Oh, it was backward.
Three ethyl, 1 methyl, cyclopentanone. And actually, I'm going to move those so they don't crash into the other one. There we go. 3 ethyl, 1 methyl, cyclopentanone. Very good. Did anybody else get that? Or close to it?
Well, I don't understand why you got the 1 methyl. I got 3 ethyl, 2 methyl.
Oh, I'm sorry. You're absolutely right. Thank you for speaking out. That was me not thinking, honestly. I had like momentary lapse of intelligence. But yes, no, it should be 3 ethyl, 2 methyl. You're good. 3 ethyl, 2 methyl. And I think that's actually what Frank said. So,
He said it. He didn't have it in alphabetical order, I don't think.
oh, I'm sorry. What would you say?
He didn't have it in alphabetical order. He started with the methyl before the ethyl.
Oh, that's right. That's right. Yeah, because you definitely need it in alphabetical order. But yep. So that would be your answer. Well, very good. Now, as I mentioned to uh, well, as most of you already know, I have to run off to my appointment, so we're gonna have a short session this time. So we'll probably have to stop here. But thank you so very much for coming, and I think we may have another session to kind of finish this up, and then we can go into the next step.